Hello everyone, and welcome to the OptiFish Partner Spotlight, a series that brings you closer to the people and innovations shaping the future of sustainable fisheries. I'm Lia Kasopoulou from Reframe Food, and as the Communications Manager for OptiFish, I'm happy to guide you on this journey. In today's episode, we'll be discussing the role of monitoring technologies in industrial pelagic fisheries with Jordan Feekings from DTU, the Technical University of Denmark. Jordan is part of the National Institute of Aquatic Resources, DTU Aqua. So welcome, Jordan. Thank you for being here today. So can you explain what pumping means in the context of industrial pelagic fisheries?
So pumping is the process of taking the catch from the net and pumping it onto the vessel. So it basically entails that a big pipe is placed in the water and the catch gets pumped up from the net, be it a trawl or a seine, into these refrigerated seawater tanks on board the vessel. Prior to reaching the tanks, it's typically the catch is passed over a dewatering system, which separates the water that it's pumped up, the fish are pumped up with, from the fish.
Okay, thank you very much for making this so clear. What role do electronic monitoring cameras and DNA technology play in estimating catch composition during pumping?
So currently, the estimation of catch compositions is done by a third-party independent company who typically are obliged with EU regulations to take certain samples depending on the size of the catch. So that's done by a third-party independent company. Then there's also the fishermen that are obliged to take a sample on board the vessels before coming to harbour. At the moment, electronic monitoring and these eDNA approaches, they're not really contributing to the monitoring of these of what's actually caught. And what we're trying to do is to see how these technologies can potentially lead to more accurate and precise estimates of what's actually caught.
Okay, that's very interesting, Jordan. Now, how do these technologies improve accuracy compared to traditional catch monitoring methods?
So traditional monitoring methods, for example, these third-party independent monitorings that take place, the size of the sample that's taken is extremely small. It's around half a percent in terms of the size of the catch. So for a catch that's of 1,000 tons, for example, then you're talking about a few hundred kilos that's actually caught, or it's actually measured and worked up. And the same for the logbook estimates that the fishermen are required to do. It's in terms of a few baskets. So that leads to high uncertainties in the estimates when scaling to the total catch volume. But what we hope to do with electronic monitoring and eDNA is to be able to take, at least with eDNA, take a sample of the water and try and see whether we can actually get a more accurate estimate from that. So what we're doing in OptiFish is actually we're going through and working up the entire catch, so we get a much more accurate understanding, kind of like a benchmark of the entire catch, which we can relate back to the estimates we're getting from eDNA and from electronic monitoring. So those two technologies will hopefully give us a more accurate understanding about what is actually extracted from the ecosystem.
Okay, so accuracy is very central to the OptiFish project. What challenges do you anticipate when implementing these technologies on multiple pilot vessels in the North Sea?
Each of the technologies has their own challenges. If we take electronic monitoring, for example, in these pelagic settings, so the catches typically come on board in high volumes, and the cameras are placed over this dewatering system that I mentioned earlier. And so consequently, of the large volumes, they pass over this area at very high rates, which leads to difficulties in documenting the species correctly, so identifying them with the likes of computer vision, but also accurately estimating their lengths. So that's the challenge that we face for electronic monitoring. If you take eDNA, the issue there is the detection accuracies. So, for example, in some of these larger vessels, we're catching between 1 million and 3 million kilograms of fish per trip. And there are some species that are present in those tanks at very low volumes. And to be able to accurately, through this approach, detect those species, that's what we're trying to figure out here in OptiFish. Can we actually identify all the species correctly in the correct volumes?
Okay, thank you very much. And how can the insights from this pilot contribute to making pelagic fisheries more transparent and sustainable?
We hope that through the adoption of these new technologies, we can actually have a better enumeration of the catches, so an understanding of around what levels of bycatch are caught in these fisheries, whether any endangered species are caught. So leading to a full catch enumeration can give us a much better understanding over what's expected from the ecosystem, and then making that a much more transparent process, so we can actually show to the consumer that these fisheries are taking place in a relatively clean environment.
Okay, and finally, what are the expected benefits for fishers in adopting these monitoring technologies?
So with a better enumeration or more accurate enumeration of the total catches, this will lead to a better allocation of what's being caught onto the quotas, the better quota allocation, which in turn should play into the better management of these stocks. Having a better enumeration of catches will hopefully also lead to an increase in transparency for the fishers, for the consumer as well. And this is expected to play out in terms of better access to market for the fishers as well in the long term.
Jordan, thank you very much for being here with us today and sharing your insights about pumping and monitoring technologies in the context of industrial pelagic fisheries.
Thank you for having me.
To our audience, thank you for tuning in for this episode of the OptiFish Battery Spotlight. If you would like to learn more about the project, visit our website, sign up for our newsletter, and follow us on social media for regular updates on our project. See you in the next episode.